Hello and welcome to my video, lesson 4.2 on factors and multiples. So there are two methods in your calculator. I'll describe those as well, but we're going to focus on doing this by hand first because by hand is both faster and better, and you actually understand what's going on if you can do this by hand. So let's start off with greatest common factor. For all of these that I have like two examples of, right? I've got two examples of everything here. I highly recommend you watch me do it the first time, you pause the video, and you try it yourself the second time. So what we're going to do is try to get the greatest common factor. We will often say GCF. Your calculator uses the acronym GCD, greatest common denominator. All three of those things mean the same thing at the end of the day. So what we're looking for is greatest common factor between two different numbers, or three different numbers. Actually, we don't even have an example of that here, but that's okay. It's not the end of the world. Yeah, it's fine. So we're going to just basically do a prime factor tree for each of these numbers. Okay, now let's do it for 24. So we're going to have 4 and 6, 2, 2, 2, and 3. And now what we're going to do is we're going to start circling things that are the same in the two different trees. And at this point, there's nothing left to circle that's the same. We only looking at the bottom row, the prime factors. The 2 and the 3 are no longer the same, so we can't circle anything there. So there are 3 of those. So it's 2 times 2 times 2, and you just multiply those together. And that means our greatest common factor is 8. Okay, let's try the next one here. Same sort of thing. Pause the video right now and press play when you're ready. Okay, we're going to do a prime factor tree of this guy, which is 8 and 7, I believe. This one is 6 and 6 are two numbers that I can come up with. 8 is 2 and 4, 4 is 2 and 2, 7 can't be changed, 2 and 3, 2 and 3, and I really should have used different colors, but that's okay. There is a 2, there is another 2, a 7 and a 2 are not the same as a 3 and a 3, so that's where we have to stop. There are two 2's here, and so our greatest common factor is 4. Okay, so our calculator can actually do this if we press the math button, okay, and then the right arrow once to get to the number menu, and then scroll down. I think it's number 9 gives you the button here is G. Well, I think it's lowercase actually, GCD, and then I'll add a bracket as well. Okay, so what you're going to do is type that in exactly. So you're going to get in your calculator GCD bracket, and then you're going to type in one of these numbers, 56, and then you're going to press the comma button, then you're going to put in the other number, 36, and you can get an answer of 4. Now, the problem is if you have like 3 different things, it's easier to do it with a factor tree than it is with the GCD button on the calculator. But you can if you want to. All right, let's continue on to the least common multiple now. So least common multiple of the following numbers, well, basically what you should do is you should just skip count with those numbers. So I'm going to skip count with 6. 6, 12, 18, 24, 30, 36, we'll stop there for now. Let's start the other one and see how far we get. So we get 9, 18, 27, 36. Okay. Excuse me. And you can probably see already that we have a lowest common multiple of 18. So 18 is our lowest common multiple between 6 and 9. Oftentimes, if you have just two numbers and you're being asked the lowest common multiple of 2 and 3, Oftentimes, the easiest answer is just to multiply them. So 2 times 3 is 6, but it's not always going to work. So in this case, 6 and 9, lowest common multiple is 18. If you multiplied them together, it would give you a multiple. 6 times 9 is 54, but it is further along. So you can see here that, if we kept going, we'd have 42, 48, and then 54 finally. And in blue, we'd have 45 and then 54. And if we circle all the ones that are common multiples, you can see that we eventually do get there, but sometimes you have a number that is smaller than if you just multiplied it. So 18 in this case. All right, let's take a look at 10 and 8. I recommend you pause the video at this time and see if you can try this yourself. All right, so we have 10, and we're just going to skip count. 20, 30, 40, and we could keep going, right? As far as we want. I always recommend at least stop once you get to the point where you know for sure that it would be one of them because it's multiplying together. So stop at least at 80. If you stop earlier, you can, always keep going if you need to. Now let's skip count with 8. So 24, 32, and 40. All right. So we have 40, and 40 is our least common multiple. Again, we can do this in our calculator. There's a button very similar to before, math. Then you go to the number menu, which is over to the right by 1. Then I believe it's number 8, which looks like this, least common multiple. It's going to be in brackets, and you're going to put in the two numbers. So like 10, comma 8, bracket, and then it will spit out the answer of 40. All right, so here are two word problems. Oh, it's interesting. I think I thought I put this as, there you go, like that. There you go, a little bit better. I'm just going to give myself a little bit more room to work with. There you go. Okay, so what is the side length of the largest square and how many squares would be used that could tile a rectangle with sides 14 feet by 28 feet? So what's going on here? So the key word here is largest. If it tells you largest, you're probably using greatest common factor. Greatest common factor, right? So let's just take a look at what this kind of looks like. So we have 14 by I made it silly. Let me just make this number better. Instead of 28, 28's too easy. Let's do 35. Yeah, that's much better. We're doing 35. Okay, so there you go. So we have a rectangle like this, and the question is, how many times can we, divide it up like this to make perfect squares in order to, actually make sure we have perfect squares inside? And the way to figure this out is to do a GCF, right? So we have 14 and we have 35, and we're going to try to find the greatest common factor. So 14, the prime numbers are just 2 and 7. 35, we have 7 and 5. And actually, that's it. That's all. We can't do any more than that. So all we're going to do is take that number, and that would be our side length. Okay, so if we think about it in terms of the drawing here, if we broke this up into 5 sections on the top, each one of those would have 7. I'm going to, like 7 feet, right? So 7, 7, 7, 7, 7. Add them all together, you get 35. And if you think about along this side, it's 7, 7 to get 14. So the largest square that can tile this would be 7 by 7. So the answer is 7 by 7 feet. All right, so this next one is a very similar type of question, except that it says the smallest square that can be created by a triangle of sides that and that. So basically, there is a triangle here of, let's just maybe make it like this. A triangle, maybe it's even less. There you go, 20 by 15. And the question is, how many, times do we have to move, like put it down in order to get a square, right? So, like before, all you're going to do is you're going to skip count. Okay, and then you're going to skip count the other one. 20, 40, 60. Now you can see here that we have the least common multiple here. Least common multiple, smallest, that's the hint, right, to get there. So least common multiple of 60. So we're going to add squares until we have 60. So 15 plus 15 plus 15 plus 15. My drawing is not super perfect, but you kind of get the idea there. And we're going to do the same thing with the 20 side. So we add those until now we have 60 along one side and 60 along the other side. And now we have tiled it with 12 total rectangles. And the side length of the smallest square that can be created is a square of 60 by 60 centimeters. All right, I hope this video helped you understand factors and multiples a little bit better. And good luck!